Cloudaeon had the pleasure of hosting M&S in India recently. During M&S's visit, we walked through a series of accelerators that Cloudaeon had built in its innovation lab. Cloudaeon has developed the C3 model to ensure these accelerators solve a business problem, and that is demonstrable on at least one of three axes: enhanced capability, increased capacity, or improved cost efficiency. The demo you'll see today registers on all three. The reason we built this accelerator was to save a significant amount of manual effort mapping, moving, and validating data between Synapse and Databricks to allow Synapse to eventually be decommissioned without impacting business as usual. We expect the accelerator to save a little under 1,300 hours of manual work. And being an automated process, it can be run many times, offering significant flexibility compared to the alternatives. Let's get into it. What we're going to demonstrate in this video is how Cloudaeon's accelerator migrates Synapse data to Databricks SQL. In Databricks Notebooks, we've created a workflow to automate the replication of data from Synapse to Databricks in the correct format. The workflow comprises 4 steps: the init script, which initializes all the log tables, copy tables, and parameters. Step 2 is the data copy notebook. Step 3, the data conversion for Parquet, Delta Lake, and Delta tables. The final step is the reconciliation of the migration completion in Databricks. We've built this view in Databricks to visualize the status of the migration as each job runs. We'll check back on it several times. It shows an initiation script and then 3 acceleration steps: data copy, conversion schema, and reconciliation. Let's look into the Synapse data warehouse. Here you have this schema named WWI. It contains dimension tables and fact tables. This is the data we're going to migrate from Synapse to Databricks. These 14 tables have been trimmed down to 1,000 rows for the purposes of this demo. In a real application, there'll be more than 6,000 tables and 3,000 rows. As we open one of the fact tables, we can see the data types that it contains. There are 25 different types. We'll ensure these are accurately migrated as we progress through this demo. The initial script contains the parameter configuration for connection to the Synapse tables in the WWI schema. As the process runs in the background, let's look at the initial script. You can see an Azure resource group which has been pre-configured. This contains the Synapse server, and that in turn has a dedicated SQL pool which is to compute for the Synapse server. Then you see the WWI schema mentioned earlier. That has the fact tables, and the views will migrate from source. On the Databricks side, you see the Premium Edition with Unity Catalog pre-configured. Before we start the migration, we need to ensure the AD group members are given the correct permissions for the target as those that they have on the source, as these will be copied across into Unity Catalog. A point to note is that data will be transferred into AWS Gen 2, where there is an allocated storage container for the migration. It's in the AWS container that the configuration parameters for the migration will be stored. If we go back to our Databricks visualization of the workflow, we can see that the init script has completed and the data copy has begun. By looking into the AWS container, we can see that the source files are now being written to the target as we move to the second step in the workflow, the data copy. There are connections in Unity Catalog that connect source and target. For example, the WWI schema in the Synapse warehouse, from where we are copying the tables, is mirrored in the target, showing where the files are being written to in the target AWS container. Going back to our run status, data copy has been completed and the next step has been started. This is the log table of data copy status. A timestamp is created when the data is copied. You can see the table is created with parameters of source and target written to a column. The source and target row counts are recorded along with the time taken to process the migration. Further columns indicate the success of the workflow. Returning to our run status, we can see the third step in our workflow, the conversion schema, has been successfully completed. We can now move to the last step, the reconciliation. The script does the reconciliation of every object. It provides a checksum of rows in both tables and views, along with the data type for additional confidence in the migration. As the reconciliation runs, it shows entries for each of the 25 data types in the fact table, count of source and target columns, a column count match, the same for rows, and a checksum for validation. To ensure the data in the tables is correct, we can check the Power BI dashboards. First, we check the numbers in the dashboard linked to Synapse, then compare it with the same dashboard linked to Databricks. We can see here that both dashboards match. We go further and produce a dashboard of the reconciliation, ensuring we have matching counts in both Synapse and Databricks warehouses. Behind both counts, we have another view showing the entire table with all the data types. Again, both are matching. Returning for the last time to our run view, we can see the reconciliation has successfully completed. We have built an automation of the Synapse to Databricks migration, ensuring that all tables, views, and roles have been validated in the accelerator to give confidence to decommission Synapse. What we've demoed here is an accelerator that is unique to Cloudaeon in its ability to migrate data from Synapse to Databricks in a fraction of the time it would otherwise take. The accelerator is exclusively available for M&S to use immediately and commence the movement of 6,000 tables, 3,000 views, and 600 roles. We're ready to start when you are.